Hi, in our previous lesson, we learned about the types of bond formation, and also one of the types of bond we have mentioned is the electrovalent bond, otherwise known as the ionic bond. In today's class, we'll be learning more about the electrovalent bond. I know you are curious. What is an electrovalent bond? You see, an electrovalent bond involves the transfer of electrons from metallic atoms to non-metallic atoms during a reaction. Chemical reactions are as a result of atoms of elements trying to get the number of electrons in their outermost shell to achieve the stable duplet or octet configuration. So, the type of combination that involves the transfer of electrons from one atom to another atom is called electrovalent or ionic combination. It takes place between the atom of a metal and the atom of a non-metal, where there is a transfer of electrons from the metallic atom to the non-metallic atom during a reaction. This metallic atom donates electrons and becomes positively charged, while the non-metallic atoms accept electrons and become negatively charged. An example of electrovalent bonding is the reaction between sodium and chlorine to produce sodium chloride. Metallic sodium Na2 has atomic number 1 with 1 electron in its outermost shell. Non-metallic chlorine Cl has atomic number 17 with 7 electrons in its outermost shell. So, to achieve an octet configuration, sodium will transfer the lone electron in its outermost shell to chlorine with 7 in its outermost shell to complete 8. Do you see that? Now, sodium hence becomes positively charged. We have Na plus charge and chlorine becomes negatively charged, that is Cl minus, and they both have the octet 8 electrons in their outermost shell. A strong electrostatic force results from this combination that holds the oppositely charged ions together, called an ionic bond, and substances formed as a result are called ionic compounds. So, let us define electrovalent or ionic bond. You see, an electrovalent bond involves the transfer of electrons from metallic ions to non-metallic ions during a reaction. Now, what are the properties of ionic compounds? Let's see. 1. They are solids at room temperature. 2. They contain oppositely charged ions. 3. They dissolve readily in water and in other polar solvents like ethanol. 4. They have high melting and boiling points. 5. They are good conductors of electricity when they are in molten or in aqueous form. So, it is clearly seen from our lesson that elements with low ionization energy, e.g. sodium, Na, potassium, K, and other alkali metals which can give out electrons to become positive ions, readily form ionic bonds with elements of high electron affinity, e.g. the halogens. I hope you enjoyed today's class. See you next class.